Hello, it's team 5. It's Isha here from team number 5. We are going to discuss about research paper on software security specifications and design, where the main motive is to highlight how software engineers and practitioners are mixing things up. I will share my screen for the document. So here's the document. Our first section is introduction. Since the term software engineering was first used in the late 1960s, software engineers have worked to create software that satisfies user needs, which are expressed as both functional and non functional requirements, while observing to financial and schedule boundaries. As our understanding of the nature of software and its requirements grown, multiple theories of software processes have been developed, delivering what customers need from the software to run their businesses and fulfilling their functionalities within the traditional quality requirements related to efficiency, reliability, and knife security was and continues to be the main focus. Currently, naive software security that puts safety first. It is insufficient to provide software users with password protected accounts that have specific right. We regularly find that a large portion of software is in poor quality and has serious weaknesses in security. Hackers are becoming more and more interested in attacking software due to increasing amount of data generated on a daily basis that involves every aspect of our lives. The widespread use of the internet and the massive development of web-based and mobile applications. However, standard network boundaries for the next part, systems for detecting and avoiding intrusions, firewalls, and antivirus software have not been able to prevent incidents using software. This is a result of hackers concentrating more on software attacks that take advantage of undiscovered risks. Therefore, the liability is now back on the software development community to use secure development process models to create more secure applications. As a result, a number of projects have been launched to address security throughout the software development life cycle, which is SDLC. Industry models like Microsoft Security Development Lifecycle, descriptive activity surveys like building security in maturity models, and standards like ISO, IEC 27034 are all included in this. Unluckily, exposed software products are still created and successful attacks never stop. Even with all of these efforts to address security requirements during the development process, this indicates that additional research may be necessary as the method. The security requirements are required during the requirement and design phases may not be appropriate. In this research project, this is what we aim to investigate. The concept of software security involves designing software to withstand attackers and still perform as intended. This involves implementing software techniques that address security issues early in the software process itself. This is how the remaining part of paper is structured. Section 2 reviews the literature on software security and related fields are described in this section. Section 3 addresses the methods, how researchers and practitioners are mixing the things up. Section 4 will address the methods and the security in the requirement phase. Section 5 addresses the security in the design phase. Potential restrictions are covered in Section 6. The paper is concluded and the future work is presented in Section 7. Now we will move to Section 2, which Hetali will review the literature on security in requirements and design phase. Over to Hetali.
The second part of this research paper, that is literature review, in which there is software is being developed for decades until now, and in the past software was simpler and didn't need to worry much about security because it mostly worked offline. But now, with everything being connected through the internet like smart devices and IoT, software has become more complex and vulnerable to attack from hackers. So while technology has advanced, the way we develop software hasn't always kept up with the need for security. Traditional development methods focused more on making software work well and quickly rather than making it secure. So today, hackers are constantly finding new ways to break into systems, and it's becoming clear that security needs to be a top priority in software development. But figuring out how to make software secure is still a relatively new field of research, and many developers are not experts in security. This means that while developers are expected to make secure software, they often do not have the necessary skills or knowledge. As a result, they are unintentionally create vulnerabilities that hackers can exploit. So there's a growing need to better understand how human factors affect software security to improve the overall security of the software which we use every day. So developers often lack the necessary knowledge to prioritize security in their software development process. They focus more on making sure the uh, software works properly and meets performance goals rather than on security. This can lead to vulnerabilities in the software that hackers can exploit. Some researchers suggest using specialized tools and APIs to help developers create more secure code. Blaming developers alone doesn't solve the problem. It is also important to address organizational and cultural issues that impact software security. This research mainly focuses specifically on improving security during the requirements and design stages of development. So the sub part of this literature review is security in the requirement engineering phase, and which is like requirements engineering is about figuring out what a software system needs to do without getting caught up in the details of how it will work. So this phase focuses on defining both the functional requirement, which is what the software should do, like letting students register for courses, and the non-functional requirements like constraints or conditions such as encrypting students' data for security. However, there's a challenge in clearly defining and measuring non-functional requirements, which can make it hard to specify security requirements effectively. This means that while we know what the software needs to do, it's not always clear how to ensure it does so securely. So security requirements at the system level focuses on keeping the system's information safe and secure. Different methods have been developed to identify and specify these security requirements effectively. So one approach is using abuse cases or misuse cases which model harmful activities by malicious actors. These models help engineers understand potential security threats and organize requirements better. Some researchers have also combined use and misuse cases in diagrams to represent both legitimate and hostile activities. Other techniques include mel activity, swimlane diagrams, which capture attacks alongside regular activities, and models for structuring and reusing security requirements. These methods help ensure that security is considered from the very beginning of the software development process and not just as a afterthought. So the second subpart of this literature review is security in the design phase. So the during the software design phase, designers create the blueprint for the system, making decisions on technology and platforms. However, many development teams don't consider security at this stage or only handle it informally. Neglecting security in design can lead to complex and flawed architectures that are prone to security issues. Today, security is recognized as essential at all stages of development, including design. So, researchers are practitioners are exploring ways to integrate security into the design phase, sometimes by extending existing modeling notations like UML. For older systems lacking security features, some purpose separating security concerns into distinct services, allowing for easier retrofitting of security measures. At a detailed level, security design patterns are being developed to address common security challenges. These patterns build on traditional design approaches to create more security systems. So, the Sumit will address about how researchers are mixing things up, and that is the third part of our research paper.
Well, according to research, human impact on secure software development cannot be overlooked. While developers are often held accountable and vulnerability, it is argued that the requirement engineers and designers should share equal responsibility for any security follow. Unfortunately, the rush of development secure the software has led to a task and practices among engineers, resulting in departure from established best practices. Moreover, certain new terminology extract from well-known concepts have been inadequately integrated into the requirement of design consent. For instance, involving user and stakeholder in developing abuse, misuse case model can be ineffective as they may lack of expertise in security technology. Not all known threats are universally applicable of the system, and engineering and stakeholder in the security design discussion may be limited by the understanding of the detail of security threat. The term of abuse misuse case can be misleading. It is state the vulnerability is the link of the user action, neglecting the role of hackers. Consequently, in the term of threat modeling, it is practiced may be more appropriate practically for designer to motivate security needs to guide and indirect design decision. Furthermore, the developers the expect to the various security threat and vulnerability, often leading to overload the development of vulnerability code. Vulnerability code is the practice the searching of the web reusable code of address the can it is its result in secure code, and there is a web cyber attack is also possible. Additionally, software may be receive the vogue of incomplete non-functional requirement from the requirement engineer, promoting the define and requirement themselves. According to that, the terminology extract well-known concept has been integrated to requirement of the design. Now, Isa will highlights the heading of security in requirements.
Thank you, Sumit. Section 4 is handling security in the requirements engineering phase. It has not been demonstrated that introducing security awareness programs to the development team and stakeholders who will specify requirements will help them specify security requirement. This is because during the development phase, the main actors involved in breaching the security, such as competitors or hackers, are not available. When adding new procedures or benchmarks to the requirement process, researchers and practitioners should exercise cautions so as not to hinder and further postpone the development process. The issue is whether users and clients are interested in learning about the specifics of how their systems can be misused or abused, as well as how to safeguard it. Customers and users will voice security concerns during the requirements engineering phase, typically at the system level, at a high level of abstractions, without worrying about how to put them into practice. This fits in with what we said when we suggested that stakeholders should specify their security objectives as non-functional requirements, which is high level requirement during the requirement engineering phase. A light security requirement gathering information process may result in incomplete and untrue requirements that will be networked by the designer or architect and increase the security depth. This can happen when stakeholders are involved in security awareness programs, writing misuse cases, or discussing the design issues in detail. Now we will move to section 5, which is to discuss about handling security in design phase. Hitali is going to discuss these methods. Over to Hitali.
Thank you, Isha. The fifth part of this research paper, which is handling security in design phase. So, designing secure software isn't easy as it involves balancing security goals, design choices, and potential threats. This creates a three variable problem where changes in one area affect the others. To address this, specific analysis tasks are needed at the intersection of these variables. Risk analysis conducted during the requirements phase helps identify potential risks using scenarios. Security design analysis focusing on vulnerabilities and attacks is crucial during the architectural design phase. Various models like STRIDE and CAPEC aid in this analysis. The design process translates security goals into concrete design choices, with each phase having specific tasks. Mixing up practices between requirements and design phases can lead to vague or incomplete requirements, making it harder for designers to do their job effectively. The table 1 outlines key security related tasks in both phases for clarity, and the next topic, which is limitations, and Sumit will discuss about it. So over to Sumit.
Sumit, are you there?
Thanks, Hitali. Well, there are many drawbacks of developing security conscious software is described about lacking maturity. In this field, still evolving, and there are many huge gaps to understanding and solution. Well, it is not well secure. It leads cyber attacks also. After that, the researcher conducting an ordinary literature review due to relative novelty of the topic and literature review leads a less structured and accurate data uh, compared to systematic review. After that, one another is a systematic review require is a another limitation, which is a comprehensive as well as structured approach to gathering and analyzing, which may be difficult, limiting research of field rapidly changing. The researchers suggest that more precise literature review in future. The implies the importance of the further investigation as well as analysis of the advancement understanding or cyber attacks. It's not well secure as well as well developed. So lastly, Isa will give you conclusion of the research paper.
Thank you, Sumit. Last but not the least, we are going to conclude our research paper. So the section 7 is conclusion and future work. When defining the security requirements during the analysis and design phases, different researchers and practitioners are combining some practices and deliverables together. This creates inconsistency around secure software development and introduces error into the process of developing a software. The talks in this research provide light on the advancement made in the field of secure software analysis and design, as well as the issues and errors that practitioners and researchers have encountered. In order to address these incompatible activities and the suggested flow of practices in the two phases, we proposed a few solutions that stick to the fundamentals of the requirements and design concepts. The recommended changes needed to be made to the secure software procedures that are currently in place. In order to make the final software more robust, we think that more research is still required to enhance the software analysis and design phases. Further research is necessary because the secure development process should begin with design rather than the requirements and then iterate between the two phases. In that way, we can avoid the security concerns of the software development in future. That's it for our research paper. So it's the end of our discussion now. Thank you.